This is Algebra 3, section 7.2, part number 2 of our notes. This is going to be the normal distribution, and we've been talking about finding probabilities and areas underneath the normal bell curve. All right, here's the last slide where we left off, and we're going to look at some applied examples. Here we go. Area under the curve and probability. Assume that baseball batting averages for the 2004 New York Yankees are normally distributed with a mean of 0.283. So let's write that down. And a standard deviation of 0.008. This is actual data from 2004. All right. What is the probability or percentage that Derek Jeter has an average of 294 or greater? And so the first thing we always want to do is draw our normal bell curve. And of course, we are operating under the assumption that batting averages are normally distributed. Let's put the mean in the middle, 0.283. And now let's figure out what probability or shaded region we have to find. So we want the probability that Derek Jeter has an average of 0.294 or better. So we're going to put greater than 0.294. 0.294 is above the average. So I'm going to draw a straight line here, and that represents an average of 294. And we want to say greater. Okay, now let's set up our normal CDF lower, upper, mean, standard deviation. That's how we're going to use the graphing calculator in order to do this. The lower bound will be 294. .294. The upper bound goes on to infinity, goes all the way forever. So we just need to pick a really, really large positive average, and we can pick something like 1,000. We don't need a huge number in this scenario because 0.283 is the average and the standard deviation is so small. So we could pick 100, we could even pick 10 and probably get a pretty good answer. But we'll just stick with putting 1,000. And where the mean is 0.283 and the standard deviation is 0.008. At this point, we need to put that information into the graphing calculator. Here is a sample graphing calculator, and I'm going to go to second distributions. The second one there is normal CDF, meaning cumulative distribution function, where the lower bound is 0.294. The upper bound, we want something really, really huge. The mean is 0.283 with a standard deviation of 0.008. Let's put that in there and see what happens. We get an answer of 0.084, and we'll round it up to 6. 0.0846. Now back to the question, what is the probability that in a given season Derek Jeter has an average of 294 or better? Then we would say that that is about an 8.46% chance. Naturally, you can ask yourself, is this a good representation of the data or not? Because Derek Jeter is a Hall of Fame baseball player and was a great hitter. And so you might think that the data might be skewed and he has a better than 8% chance of hitting 294. So there are different ways to look at data, and of course we have to interpret it inside of the real world situation. Here is another. Tornadoes. Since 1950, Oklahoma encounters on average 56.2 tornadoes per year, with a standard deviation of 10.6. And this is actual data. What is the probability that next year there will be between 30 and 60 tornadoes? At this point, I would like you to pause the video, try the problem on your own, see if you can draw your bell curve, shade the region, and use the cumulative distribution function to find the answer. Go ahead. All right, here we go. I will draw my curve. The mean is 56.2. This one's a little bit different from the previous question because we're looking for in between 30 and 60. So 30 is below the mean, but 60 is just above it. So we're looking for a shaded region. It's about that wide. Remember that it does not matter with a normal distribution because the little sliver is so small. It doesn't matter whether you put less than or equal to or just less than. So we'll stick with that right there. And we'll say this is going to be equal to normal CDF from 30, the lower bound, to 60, the upper bound, with a mean of 56.2 and a standard deviation of 10.6. Once again, let's put this into the calculator. And we're going to say second distributions, normal cumulative distribution from 30 to 60 with a mean of 56.2 and a standard deviation 10.6. And so the answer would be 0.6333 because we're going to round that last number up. There you are. Please comment on this video in order to earn credit, and then have a nice day.